So let's now discuss complex numbers and their functions. Numbers and functions. First, in the first section, first half, in the first half of this section, we basically see what is a complex number, we revise some basics of complex numbers before going to complex functions. Okay, so let's begin. Now, let's begin with the question. X square is equal to 2 and x square is equal to minus 1. Well, when I solve this, I have a solution in a real domain, right? It's root 2, which is again 1.414 to try to solve it, and so it belongs to a set of real numbers. But this doesn't have solution even in real numbers. So the objective is, so what has happened is, over a period of time, in order to solve this quadratic equation, real number system is basically extended to a larger set. Okay, and which we call as a complex number system. So over the period of time, you can just recall, initially there were positive numbers, then in order to incorporate negative numbers, then we extended the positive numbers, then came a set of integers, then in order to include so that's how the extension of real numbers has come to the complex number system. That's like how the integers evolved into them. Now to find out, say, if the numbers like 1 by 2, the set of integers were again extended for rational numbers, and then so on. And the last extension, the extension is going on. Last extension, in order to consider the root of negative number, the larger or the real number set was extended to complex number system. You can just now we'll go to basic definition of a complex number. Okay, so first of all, we define the symbol I first. We define the symbol I, which is called the imaginary unit. To have property like this. So I has been defined in this way. Square of I gives -1, or the square root, or I is basically defined as the square root of -1, and it is denoted by root -1. So that's how, why it is called imaginary is something difficult to imagine, right? You have to just imagine. In real, you cannot say, if you have 2 or 3 or 2 by 3 or 4 by 5, you can just sort of imagine. So those are real numbers. But these, in practice, difficult to, what is root -1? It is difficult to, in practical sense, it's difficult to imagine what is, you have to just, that's why the name has come imaginary. So the basic definition of complex number, once I has been defined, then okay, so about I have another point here. I is basically not a real number, okay, because obviously no real number has a negative square. Okay, all real numbers, if you square them, it will be a positive value. Okay, so I is not a real number. That is one thing. I is not a real number. I is not a real number. Okay. So now word about complex number. So this is a basic definition. Complex number is an expression of the form a plus ib where a and b are real numbers and I is the imaginary unit. So this is together is definition of complex number. So basically a complex number is defined to have an expression of the form a plus ib, where a and b are real numbers and I is the imaginary unit which was just defined previously. So for example, 3 plus 2i, 7 by 2 minus 7 by 3i, okay, I pi and minus 3. Okay, all these are examples of complex numbers. Well, here a thing to note here is that okay, a plus ib, this is in the form a plus ib, this is also in the form of a plus ib, where a is 7 by 2, b is minus 7 by 3. This is a is 0, b is 5. But what about the last example? Last example shows that every real number also can be regarded as a complex number. You can always consider minus 3 as minus 3 plus I into 0. So all the real numbers can be regarded as complex numbers. So we are going basically from very low level of, from basically from start, okay, all the very basics of complex numbers, okay, and it is often seen that, or it is often for a convenience, it is often convenient to represent basically a complex number which is of a plus ib form by a single letter, okay, by a single letter. So this can be either W or Z. So most of the time it is Z. That's in, so W is A plus IB, Z is X plus IB. So this is how each of the complex numbers are just represented by single number. And remember that if W is equal to Z, that happens only if W is equal to Z, it will happen if and only if your real part is equal and the imaginary part. Imaginary part means something which is attached to y. So all these two have to be equal. Then only you say that two complex numbers are equal. This is important point. Coming to another important point. So if z is x plus iy is a complex number, where your x and y are real, we call x as the real part of z and denote it by re of z. That's what we call x as the real part of and also we call y as the imaginary part of z and denote it as im of z. Okay, so that's the thing. Real part of z, it is written like this: real part of x plus ib, which is x, and imaginary part of z, which is x plus iv, which is y. Okay, so note that both real part and imaginary part of a complex number are real numbers. Okay, so both the real part and the imaginary part are real numbers, but only thing is the one that is attached with I is called the imaginary part. So for example, 3 minus 7i, 3 is the real part, the imaginary part is 3 minus 7. Okay, so this was about real part and imaginary part. Now come to the graphical representation.